Space is vast. It's teeming with stars, planets, and mysteries beyond our wildest dreams. In 2017, humanity got a glimpse of one of these mysteries, a visitor from another star system. We called it Oumuamua. Oumuamua wasn't like anything we'd ever seen before. It zipped through our solar system, moving too fast to be trapped by the sun's gravity. This cosmic traveler was on a one-way trip through our neighborhood, and we were lucky to catch a glimpse. The discovery of Oumuamua sent ripples of excitement through the scientific community. Here was a chance to study something from beyond our own solar system, a tangible piece of the cosmos from parts unknown. But as we observed this interstellar interloper, more questions arose than answers. What was it made of? Where did it come from? And perhaps most intriguingly, just how big was this enigmatic object? One of the most striking things about Oumuamua was its shape. Unlike most asteroids and comets in our solar system, which tend to be roundish, Oumuamua was incredibly elongated, like a cosmic cigar. Imagine a giant cigar, tumbling end over end as it hurtles through space. That's what Oumuamua looked like to our telescopes. Its unusual shape sparked numerous theories about its formation and composition. Some scientists believe that Oumuamua's elongated shape could be the result of a violent collision in its home system, billions of years ago. Others speculate that it might have been stretched and molded by the gravitational pull of a nearby star. Whatever the reason for its peculiar form, Oumuamua's shape was our first clue that this was no ordinary space rock. It was something entirely new, something that challenged our understanding of the universe. Determining the size of an object millions of miles away is no easy feat. Astronomers have to rely on indirect methods, like analyzing the light reflected by the object. In the case of Oumuamua, its brightness fluctuated dramatically as it tumbled. These fluctuations gave scientists clues about its size and shape. They concluded that Oumuamua was likely between 500 and 3,000 feet long. To put that in perspective, imagine the Empire State Building lying on its side. That's roughly the size of this interstellar visitor. However, due to the limitations of our telescopes and the vast distance, getting an exact measurement of Oumuamua's size proved to be a challenge. Despite the challenges, scientists were able to learn a surprising amount about this celestial visitor. The way Oumuamua reflected sunlight suggested that it was a relatively dense object, perhaps composed of rock and maybe even some metals. The discovery of Oumuamua sparked a wave of speculation and excitement in the scientific community and beyond. With limited data, scientists and the public alike couldn't help but wonder, what exactly was this mysterious object? Some theories suggested that Oumuamua was a chunk of a planet ripped apart by the gravity of a star. Others proposed it was a remnant from the early universe, a cosmic fossil drifting through the void for billions of years. Perhaps the most intriguing theory, though highly speculative, was that Oumuamua could be an alien probe sent from another civilization to explore the cosmos. This idea, while captivating, lacks concrete evidence and remains firmly in the realm of science fiction. While we may never know for sure what Oumuamua is, the very act of speculating pushes the boundaries of our imagination and fuels our desire to understand the universe and our place within it. Section 5. Cosmic Puzzles and the Search for Answers. The study of Oumuamua is a testament to the power of science and our insatiable curiosity about the universe. Despite its fleeting visit, this interstellar interloper provided us with a glimpse into the vastness and diversity of the cosmos. Oumuamua's arrival highlighted how much we still don't know about the universe. It challenged our assumptions about the nature of interstellar objects and raised profound questions about the possibility of life beyond Earth. Though Oumuamua has long since left our solar system, its legacy lives on. It serves as a reminder that the universe is full of surprises, and that every now and then, something truly extraordinary comes along to challenge our understanding of the cosmos. The search for answers about Oumuamua continues, with astronomers eagerly awaiting the next interstellar visitor, hoping to unravel more secrets hidden within the vast expanse of space. Section 6. The Great Size Debate. While we have a general idea about Oumuamua's size, pinning down its exact dimensions proved to be a real head-scratcher for astronomers. It's like trying to figure out the size of a flying bird from miles away, while it's doing flips and spins in midair. Oumuamua's brightness flickered as it tumbled, sometimes appearing brighter, sometimes dimmer. This variation in brightness, along with its incredible speed, made it difficult to get a precise measurement. Imagine pointing a flashlight at a spinning coin in a dark room. Sometimes you see the full face of the coin, making it appear larger, and sometimes you only see its edge, making it seem smaller. That's similar to the challenge astronomers faced with Oumuamua. Despite these difficulties, scientists used clever techniques and complex calculations to estimate Oumuamua's size. Their best guess? It's somewhere between the length of a football field and the height of the Eiffel Tower. Section 7. A shape out of this world. Now let's talk about Oumuamua's shape, because this is where things get really interesting. Unlike most space rocks we've encountered, which tend to be round or potato-shaped, Oumuamua is long and thin, like a cosmic cigar or maybe even a giant space baguette. This peculiar shape had scientists scratching their heads. Was it always this elongated, or did something happen to it along the way? Some theories suggest that it might have been stretched and pulled by the gravity of a star, like a cosmic piece of taffy. Others believe that Oumuamua's shape could be the result of a collision in its home system, billions of years ago. Imagine two giant space rocks smashing into each other, creating a shower of debris, including our long, thin friend Oumuamua. Whatever the reason, Oumuamua's shape is a testament to the incredible forces at play in the universe, shaping and molding objects in ways we are only beginning to understand. Section 8. Echoes in the Dark, How We See Oumuamua. You might be wondering, how do we even know what Oumuamua looks like when it's so far away? Well, we don't actually have a high-resolution photograph of it like we do of planets in our solar system. Instead, we rely on something called light curves. Imagine Oumuamua as a disco ball reflecting light from the sun. As it spins and tumbles through space, the amount of light it reflects back to us changes. These changes in brightness are recorded by telescopes and plotted on a graph, creating what we call a light curve. By analyzing the patterns and fluctuations in Oumuamua's light curve, astronomers can infer its shape, size, and even some of its surface properties. It's like trying to figure out the shape of a dancing shadow puppet by observing how the light changes behind it. It's a bit like detective work, piecing together clues from faint echoes of light to unveil the secrets of this interstellar visitor. Section 9. Alien Probe or Natural Phenomenon. Now let's address the elephant in the room, or rather, the alien spaceship in the solar system. Oumuamua's unusual shape and unexpected trajectory led some to speculate that it might be an artificial object, perhaps even an alien probe sent from another civilization. While this idea is certainly intriguing, it's important to remember that extraordinary claims require extraordinary evidence. And so far, there's no concrete evidence to suggest that Oumuamua is anything other than a natural object, albeit a very peculiar one. Scientists have explored various natural explanations for Oumuamua's characteristics, such as its possible origin as a fragment of a comet or a planetesimal, a building block of planets, from another star system. While the alien probe hypothesis is a fun thought experiment, it's essential to approach it with a healthy dose of skepticism and to base our conclusions on scientific evidence. Section 10. The Importance of Interstellar Visitors. Regardless of its true nature, Oumuamua's visit was a momentous occasion for astronomy. It marked the first time we've ever observed an object from another star system passing through our own, providing us with a unique opportunity to study something truly alien. Oumuamua's arrival taught us that interstellar objects are more common than we previously thought, and that our solar system is not a closed-off bubble, but rather a cosmic crossroads where objects from other parts of the galaxy can occasionally wander through. Studying these interstellar visitors can provide us with valuable insights into the formation and evolution of other planetary systems, the diversity of objects in the universe, and perhaps even shed light on the conditions necessary for life to arise elsewhere. Section 11. Conclusion. Oumuamua's lasting legacy. Oumuamua may be long gone, continuing its journey through the vast expanse of space, but its legacy lives on. It has ignited our imaginations, sparked scientific curiosity, and reminded us of the boundless mysteries that lie beyond our own planet. This interstellar visitor has taught us the importance of remaining open to the unknown, of questioning our assumptions, and of embracing the thrill of discovery. As we continue to explore the cosmos, we can be sure that Oumuamua was just the first of many interstellar visitors we will encounter, each with its own story to tell and secrets to unravel. And who knows what other wonders await us out there in the vast expanse of the universe?